Hi, this session is on number properties. So we'll be looking at things like factors and multiples. But before we start, let's just do some revision on previous things we have learned. Okay, so I want you to calculate the following questions. And that's a square root of 10 plus 4. So these are just random test questions that you'll be having soon. Okay, so with the first one, we should be experts at this. If you ever get stuck, turn it into a fraction. So 256 divided by 3, I know that falls down and goes under that bridge or the division algorithm. So 256 is under there, 3 is out there. And now I'm going to add the most important thing, decimal, make that visible, and then add some zeros. I'll add about 3, that's all I can fit in. And now I can get started. And we know we must add the decimal in case we are left with remainders. So, first one, can 3 go into 2? No, so put a 0 and carry the 2 onto the next number. We now have 25. Can 3 go into 25? Well, I know 3 times 8 is 24, so we can fit 8 times, remainder 1. 3 into 16? Okay, 3 into 16, I know 3 times 5 is 15, so it can go 5 times, but there's a remainder 1. And now it goes on to that 0 that I got ready. So 3 into 10, yes, 3 into 10 can go, well, 3 times 3 is 9, so 3 times, remainder 1. And then 3 into 10 again goes 3 times, so 3 times, remainder 1. And I can see what is happening. So I'll stop there. I have found my pattern. And we know whenever we have a fraction or dividing two numbers, like whole numbers or decimals, there will always be a pattern. So our final answer will be written as, I don't have to put the 0 there, so 85.3 with a dot on top. That dot is saying 3 goes on forever. So that should have been your final answer. With our next one, we are multiplying with decimals. Now, you can probably work this out mentally if you remember how to do it, okay? And if you've forgotten how to do this, you must make sure you go back and watch the other lesson. But the first step is, remember, ignore the decimals. So if I didn't have decimals here, I would just have number 1. Because 0, 0 is just saying number 1. And then I would have, so that will be it, and then times, and then I would have 223. Okay? Now, what is 1 times 223? It's so easy. It's just 223. That's why this one, you could have done it mentally. Now, we don't stop there. Now we have to go back and put our decimal in. So right now our decimal is on this end. We made it visible. And now count, how many decimal places do we see in the question? How many numbers after the decimal? We've got 1, 2, 3, and 4. So I'm going to move my decimal back 4 times. I'll add a 0 on the end just so I can fill in the space. And let's go 1, 2, 3, 4. And my decimal goes there. So my answer is going to be, you can say 0.0 or 0 point. And I've got 0.223. And I'll just check on my calculator. So 0.01 times 2.23. And it gives me that answer. So I'm correct. Okay, our next question. We had 2 squared plus the square root of 10 plus 4. I think it was 2 squared or 2 cubed. So I can't remember. Sorry. I've got 2 squared here. This one's really easy. We know with BODMAS we first work out our powers. And remember, the square root is actually a power there. So square roots are also considered as powers. So 2 times 2 is just 4 plus. Now, to work this one out, whenever you have a sum under the square root, you must add the numbers first or calculate whatever's in there first. What is 10 plus 4 normally? 10 plus 4 is 14. Okay? And then we've got the square root of 14. Now, we can't actually work out the square root of 14. Put it in your calculator and you will get an irrational number. It goes on forever and it has no pattern. So you can actually leave your answer like this. I'm happy for you to leave it like that. If you wanted to get an approximate answer, then use your calculator for this step. But that's all you should have had. Now, the next question I want to do involves rounding off. On your revision sheets, a lot of you got this wrong, so you've forgotten how to round off. We'll do it in class as well, but I want to give you a head start. Now, to round off, see what the question asks you. This one says round off to 2 decimal places, okay? So that means 2 numbers after the decimal. So with the first one, that's my first step. There's my decimal point. So I'm going to count 2 numbers after the decimal. So 1 and 2. Okay, that means we can do a cutoff line, which basically says everything else past that line is going to disappear. And we're left with our 2 decimal places. But before we do that, we've got to do a check. The number after the 3, so next to this cutoff line, is 4. Now, write this down if you've forgotten this. If the number is 4 or less, this stays the same. You don't change anything. But if the number is 5 or more, you have to add a 1, in this case, to this 3 here. So the number here is 4. So because it's 4 or less, we don't add a 1. So our answer will be 2.13, and we're done. We don't change anything. But if you have a look at number 2, so once again, to 2 decimal places. So we go 1, 2. That means everything else is going to be cut off from that line, except do our check. The number after this line is a 5. It is 5 or more, which means we have to add a 1 to that 5 there. So what is 5 plus 1? It is just 6. So we end up with 8.56, and the rest is all gone. That's all we have to do. So to quickly try this one, I'll just clear the page. So try this one. Now with this one, once again, cutoff line goes here because we're still rounding off to 2 decimal places. Now this one might be a bit trickier because it involves carrying, but this is how hard they get. Now, I'll check my number, it's 7. Because it's 5 or more, I have to add a 1 to the 9. Now, this is where we simply calculate it as if we're adding. Get your decimal ready, okay? And let's do this. What is 9 plus 1? It is 10. Don't write 10 down. You put the 0 down and carry the 1. What is 8 plus 1? 8 plus 1 is 9. Nothing else to carry, so put our 2 there. So our final answer will be 2.90 or 2.9. I'll put a 0 there. That is rounded off to 2 decimal places. So the hardest one you can possibly get is where you have to simply carry. And that's how easy it is. Now, for this session, we are also looking at the following important keywords. We learned this last year in Year 7. So what I want you to do is to write them down, leave some space in between each one because you are going to have to write examples and what the meaning of each of these are. But I want you to write down whatever you remember. Okay, hopefully you can remember 1 or 2 of them, hopefully all of them. But first, I want you to have a go. Now, the first one is one of the most important ones, and that is factors. Okay, so my definition is this. Factors of a number divide evenly into that number. Evenly means we have no remainders, okay? Now, every number, this is important, every number has a factor of 1 and itself. So every number has to have 1 as a factor and also the number itself, which means, so for example, factors of 6, okay, we can see there's a 1 there, and at the end there's a 6. So when writing factors, so if I was to write factors of 6 as my example, always do this. Start with a 1, okay, and then put the actual number at the end. That has to always be the case. So factors, there's a limited amount. And then what goes in between? Let's start with, the next number is 2. Can 2 divide into 6? Yes. So 2 is a factor of 6. Can 3 divide into 6? Yes. So 3 is a factor of 6. Can 4 divide into 6? No. So we stop there. And the trick is, once you have reached halfway of the number, you can stop, because that means once you've passed halfway, nothing else can divide into that number. So I'll just add in there, there is a limited amount of factors, or finite amount, okay? Because sometimes you get confused. So with factors, there's only a certain amount or a limited amount. Now, the next one we're looking at are composite numbers, and they're sort of the opposite. So we'll just say, to prime numbers. No, so composite numbers have more than 2 factors, okay? And that's it. So for example, the numbers that divide evenly into 4. The numbers that divide evenly into 4 are 1 and 4, but also 2. Okay, so we can see 4 has 3 factors. So if we have a look at 6, Let's write down the factors of 6. We've got 1 and 6, okay? Actually, we did 6 before. Let's pick a different number. I want you to write down the factors of 8, okay? Do it first before you watch me do it. So my first step is 1 is on one end and 8 is on the other end. Now, if these were the only factors of 8, we would call this a prime number, which we're going to go into next. But I know there are more factors than just 1 and 8. I know 2 goes into 8, 2, 3 can't go into 8, 4 can go into 8, 5 can't. I've passed halfway, and I know 8 has only 4 factors now, and that's it. And because there's more than 2 factors, so more than just 1 and the 8, we call this a composite number. That's how easy it is. So composite numbers are the opposite to prime numbers. And let's move on to that. So prime numbers have only 2 factors, the number 1 and itself. For example, the numbers that divide evenly into 2 is just 1 and 2. So prime numbers can only have 2 factors. So let's look at an example. We'll use 2. So I'll just clear the page. So if I have the number 2 and I want to write down the factors of 2, my first step is I put my 1 first, the number itself on the other end, and any factors that go in the middle. But I know nothing else can fit into 2. So because I've only got 1 and the number itself, this is called a prime number. And that's how easy it is, just the 1 and itself. Now 2 is a special number. 2 is the only prime number that is an even number. Okay, so only prime number that is even. So that might be a test question. What number is an even number that's a prime number? And it has to be 2. So try this one here. Is, for example, is 9 a prime number? Okay, because we now know that every prime number has to be an odd number except for 2. So let's have a see. Let's have a look. 9 is an odd number. That's our first step. So I write down my factors of 9, 1 and 9. Are there any numbers that divide into 9? Any more numbers? Can 2 go into 9? No. Can 3? Yes, 3 can. Can 4? No. Can 5? I've passed halfway, so I'll stop. Because 9 has another factor of 3, so 3 factors in total, this is not a prime number. Not a prime number. Okay? Because 3 also goes into 9. So what I'll add on to this, we can say every prime number is an odd number except for 2. So 2 is the only even prime number. The next thing I want to look at are the highest common factor, okay? So once again, we're going back to factors, and this is really easy. Now, we use this when comparing 2 or more numbers. So for example, the highest common factor of 6 and 9 is 3. And to prove that, let's use this as an example. So what's the highest factor, we'll just clear the page, of 6 and 9, just to make sure. So I've got a 6 and 9. And we want to know what the highest common factor is. The trick is you write down the factors of each number first. So let's do the 6. What are factors of 6? Okay, so you do this one. I know factors, 1 goes on the first end and 6 will be on the last end. And in between, let's see what I can do. 2 can go into 6 and 3 can go into 6. So they're all the factors of 6. And we write the factors in ascending order. Now, that's done. Now, what are factors of 9? So factors of 9. Once again, do the same thing. 1 goes on the first end and 9 on the other. And what other numbers divide into 9? I know 2 can't, I know 3 can, 4 can't, and that's it. So 1, 3, and 9. Now that I can see the factors of each of these numbers, I'm going to compare them. I can see 1 is a common factor, 2 isn't, 3 is, 6 isn't, and that's it. So it has 2 common factors, 1 and 3. And which one is the highest one? The highest or largest number is 3. So the highest common factor of 6 and 9 is simply 3. That's how easy it is. So to do this, write the factors of each number and circle the highest common one. Now the next keyword we are looking at are multiples. And students get confused with this one. It seems to be the hardest one possible. And if we haven't played Snail Trail yet, we'll play it soon. So multiples are the products. So products mean when we multiply two numbers, it's the answer of when you multiply two numbers. So I'll use an example first. So you can write that down. So if I have 2 times 4, okay, the answer, in maths we say the product of 2 and 4 is 8. So product is the answer when you multiply, okay? So write that down if you didn't know. So the product of 2 and 4 is 8. So 8 is a multiple of 2 and also a multiple of 4. So it's the multiples are the products when you multiply a number with another number. So all you're going to do is simply count your numbers. So for example, multiples of 2. So multiples of 2, we do this. You ready? 2, 4, 6, 8, 10, and it goes on forever. So there is an endless amount of multiples, okay? When you get larger numbers, just say if I said to you, what are multiples of 13? Now, we don't really know our 13 timetables or our 14 timetables. So we can do it this way. 1 times 13 is 13. 2 times 13, whoop, you can use a calculator if you wanted to, it's 26. And these are all multiples of 13. Or you can keep adding on. So 26 plus 13, the next one would be 39, and so on. And you keep going until the question asks you to stop, basically. So let's try an example. So for the next question, I want you to do this one. Write down the first 10 multiples of 3. So you do that first. And this is how easy it is. You ready? 3 timetables are easy. So ready? 3, 6, 9, 12, 15, 18, 21, 24. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. 2 more. So 27 and 30. They are the first 10 multiples of 3, and we're done. Now, the last important keyword we're looking at are the lowest common multiples. Okay, this is also confusing for students. But if you ever get stuck, it's the same thing. So if you read this, so the lowest common multiple is when we compare 2 or more numbers, okay? When working with fractions, we say the lowest common denominator it's actually asking the same thing. So I'm sure you've heard of, when you had 2 fractions, what's the lowest common denominator? That's exactly the same thing as saying, what is the lowest common multiple? Let's do an example. Now, write this fraction down. Okay. And if you have to add this, we know we have to have the same denominators when adding fractions. So we try and find the lowest common denominator. But instead of saying that, I'm going to say, what is the lowest common multiple of 4 and 8? So I'm going to take the 4 and the 8 and work with them. So all you're going to do with this is start with one number. So I'm going to write the multiples of 4 and do that trail. 4, 8, 12, 16. I'll stop there because I think that should be enough. Now, what are multiples of 8? Starting with 8, so 8, 16, 24. And I'll stop there because I can see something that's similar or the same. Can you see a number that's right now that's in this row and in that row? Yes, we can see it's the 8. So 8 is the lowest common multiple of, So 8 is the lowest common multiple of 4 and 8, okay? As soon as you see that, you can stop. You keep going until there is a lowest common multiple between 2 numbers, okay? So if I had to work with this fraction, I can turn this 4 into an 8. 4 times 2 and 1 times 2, and I would have 2 over 8 plus 3 over 8. Then I can add my fractions. So finding the lowest common multiple is the same as finding the lowest common denominator. But the trick is, first write down your number, write down some multiples, and the same thing for the 8, and you keep going until you see a common one. And with this one, it happened to be 8. So that was pretty easy.